Welcome to the deep dive. Forget the surface level. Today we're going down into something, well, truly fundamental. Fine-tuning.
Exactly. We're talking about this astonishing precision, these incredibly narrow sweet spots that seem to underpin everything.
Right, the conditions that allow the universe, life itself, to even exist. It's kind of mind-bending when you think about it.
It really is. And today we're looking at this from vastly different angles.
We've pulled together insights covering the very laws of physics, the hidden world in our soil, the complex ecosystems in our gut.
And even the incredible order that life maintains within our own cells. It's everywhere.
And our mission really is to explore what all these examples of fine-tuning tell us about balance, about coherence.
And ultimately about health, both our own health and the health of the planet.
We know you want the key takeaways, the really interesting nuggets, without getting totally swamped in data. So that's what we'll aim for.
And, for listeners who are with us for episode 14 on quantum biology.
Ah, yes. Good point.
Think of this as sort of the bedrock underneath all that. The conditions that make those quantum effects in life even possible.
Okay, so let's start big. Really big. The cosmic scale.
Right. The fine-tuned universe hypothesis. The basic idea is that these fundamental numbers in physics.
Things like how strong gravity is or the charge on an electron.
Exactly those. They seem to be dialed in with, well, breathtaking accuracy.
And these aren't just numbers someone guessed, are they? We measure these.
We measure them. And our current theories, they can't actually predict why they have the values they do. It's a bit of a mystery.
Huh. And the implication is, if they were different.
If they were off by even a tiny fraction, the universe would look completely different. Probably lifeless.
Like how? What kind of differences are we talking about?
Well, you could have universes that just, poof, collapsed almost instantly. Or expanded so fast that nothing clumped together. No stars, no galaxies, nothing.
Wow. Okay, let's make this concrete. Give us an example. Gravity, maybe?
Gravity is a perfect one. Its strength is absolutely critical. Too strong. The universe might have just crunched back down right after the Big Bang.
Or maybe life couldn't get very big.
That too. We might all be microscopic, yeah. But too weak? Or if its balance with, say, dark energy was off?
Then no galaxies, no stars, no planets?
Exactly. No cradles for life. It's this knife-edge balance. The universe needs gravity to be just so.
And the odds against that? I read somewhere it's like tuning it to 1 part in 10 to the power of 60.
That's one of the estimates, yeah. An astronomical number. Almost literally. It's hard to even wrap your head around.
Okay, what else? The electromagnetic force.
Right. The force governing chemistry. How atoms stick together, how molecules form, its strength relative to gravity. That ratio needs to be tuned to within 1 part in 10 to the power of 40.
Another one of those impossible numbers.
It really is. If that balance were off, you wouldn't get stable atoms or molecules. The universe would just be barren.
No chemistry, no life.
Pretty much. And even just getting the right ingredients for life, like carbon and oxygen made in stars, that needs the electromagnetic force dialed in to within about 4% precision.
So the raw materials themselves depend on this tuning. Okay, What about inside the atom? The nuclear forces.
The strong nuclear force, that's what holds protons and neutrons together in the nucleus. Super important.
And if that was different?
If it was weaker, a lot of the elements we rely on might just fall apart. We could be stuck with basically only hydrogen.
Just hydrogen?
Wow. But here's where it gets really wild. If it were just a tiny bit stronger, maybe only 2% stronger.
What happens then?
Then, in the early universe, pretty much all the hydrogen would have fused into helium almost immediately.
That's bad because...
Because you need hydrogen for long-lived stars like our sun.
Yeah.
Stable energy sources. And, no hydrogen also means no water. HO. Pretty fundamental.
Right. No water, no long-lived stars. That doesn't sound good for life.
Not at all. And just getting the right amounts of carbon and oxygen depends on the strong force being tuned to within maybe 0.5%.
It's an incredibly narrow window. And wasn't there something specific about carbon production? The Hoyle state.
Ah, yes. The Hoyle state. Brilliant example. It's a specific energy level, a resonance, in the carbon-12 nucleus. It sits at 7.656 megaelectron volts.
Oh.
Now, that number itself might not mean much, but its value is unbelievably critical. If that energy level were just a tiny bit lower, maybe below 7.3 MeV.
Or a bit higher.
Right, or higher, say above 7.9 MeV, stars just wouldn't make enough carbon. Not nearly enough for life.
So the universe needed to hit that exact energy note.
Pretty much. And actually, to get the amount of carbon we see, the tuning needs to be even tighter. Somewhere between 7.596 and 7.716 MeV. Fred Hoyle predicted this state because we exist, and then it was found experimentally.
Wow. He reasoned backwards from our existence to predict a fundamental property of physics.
He did. It's quite something. And the story doesn't stop there. Making oxygen from carbon also involves fine-tuning.
How so?
There's an energy level in oxygen-16 that's deliberately off resonance, just slightly. This prevents all the carbon from getting instantly converted into oxygen in stars.
So we end up with both carbon and oxygen.
Exactly. Enough of both. And that depends on this delicate dance between the strong force and the electromagnetic force.
It really is like a cosmic symphony. Everything has to be just right. What about the weak nuclear force? It feels less famous.
It's less flashy, maybe, but still vital. It governs things like radioactive decay and some key reactions inside stars.
If it were different.
Stars essential for life, the ones that burn nice and steady for billions of years, they might not form, or they might burn out too quickly.
For example.
Well, if the weak force were, say, 10 times weaker than it is, the early universe would have made too many neutrons.
Leading to
a very rapid conversion of hydrogen to helium. Again, no long-lived stars like our sun.
So even the weak force is strong enough to shape our cosmic possibilities. Okay, one more big one. The cosmological constant. That's about the expansion of the universe,
Yeah.
right?
The cosmological constant lambda. This one. The fine-tuning is almost comical. It's so extreme. It relates to the energy of empty space itself, and it's driving the universe's accelerating expansion.
And its value is
Tiny. Incredibly tiny. Compared to what some theories might predict, it's smaller by a factor of maybe 10 to the power of 120.
wait, 1 followed by 120 zeros. That's essentially zero.
It's mind-bogglingly close to zero, and it has to be. If it were just a smidgen more positive.
The universe expands too fast.
Exactly. Everything flies apart before galaxies and stars can form. But if it were negative and even slightly larger in magnitude,
It collapses.
the whole universe would have recollapsed on itself long, long ago. No time for life. So this ridiculously precise near-zero value is fundamental to having a stable, long-lasting universe.
Wow, it's this constant balancing act. Are there other examples? What about the particles themselves?
Absolutely. Take the ratio of the proton's mass to the electron's mass. It's about 1836.
And if that ratio were different?
Chemistry would be completely different. The way atoms bond, the kinds of molecules that could form, it would likely rule out any kind of complex structures like we see in biology.
It feels like all these numbers are connected somehow. They all have to work together.
That's a key insight. They aren't independent dials. The fine-tuning seems deeply interconnected. A change in one often requires adjustments in others to keep the universe hospitable.
And we can't forget the very beginning, right? The initial conditions.
Crucial. Especially the initial density fluctuations.
Mm-hmm.
The very early universe was incredibly smooth, but not perfectly smooth. There were these tiny, tiny ripples in density.
About 1 part in 100,000, that sort of scale.
That's the rough value, yeah. Represented by Q around 10 to the minus 5. These minuscule variations were the seeds for everything.
Seeds, how so?
They were the starting points where gravity could start pulling matter together. Without them, or if they were much smaller.
The universe stays too smooth.
Exactly. No galaxies, no stars, no planets, just diffuse gas forever. But if they were much larger, chaos, black holes everywhere.
You got it. Too violent. Or maybe the whole thing collapses back too quickly. So even the starting texture of the universe had to be just right.
It's almost too much. All these apparent coincidences. How do scientists even begin to explain this?
Well, there are a few main ideas floating around. One is the multiverse.
The idea that there are countless other universes.
Infinite, maybe? Each with different physical constants? And we just happen to be in one where the constants allow us to exist because, well, we couldn't observe it otherwise.
That ties into the anthropic principle, doesn't it?
It does. The weak anthropic principle, WEAP, basically says we see the universe this way because if it were different, we wouldn't be here to see it. It's a selection effect.
Like, of course, the fish finds itself in water.
Sort of, yeah. Then there's the strong anthropic principle, SAP, which is a bit more philosophical. It suggests the universe must have properties that allow life to arise.
What other possibilities are there?
Some people propose divine design, a creator who set the dials. Others think maybe our physics is incomplete. A theory of everything.
Right. Maybe a deeper theory will show these constants aren't arbitrary at all, but emerge necessarily from some more fundamental principles.
Fascinating possibilities.
Right.
But whatever the ultimate reason, that anthropic principle highlights something key, doesn't it?
It absolutely does. It shows how these incredibly fine-tuned physical laws set the stage. They create the stable, long-lasting, chemically rich universe that's necessary for biological evolution to even get started.
It's the framework, the context.
Precisely.
Yeah.
And the interdependence is striking. It suggests a deep coherence at the very foundation of reality.
And it's not just tuning for any life, but for a universe capable of complexity, long-lived stars, planets, chemistry, observers.
Exactly. And this isn't just abstract philosophy. It connects directly back to things we've explored before.
Like our quantum biology deep dive.
Definitely. Remember discussing quantum coherence in photosynthesis or quantum tunneling in enzymes? Those phenomena rely directly on the values of constants, like Planck's constant, the electron's mass, the fine structure constant. Change those, and those delicate quantum effects in living cells, they might just disappear.
So the weirdness of quantum biology is built on this cosmic precision.
It is. The efficiency of photosynthesis, for instance, seems really sensitive to the fine structure constant. The probability of enzyme tunneling depends on particle masses. It's all connected.
Any other connections?
Well, think about track 3, mind, perception, narrative conditioning.
Huh?
The narrowness of these physical laws, these rules of the universe, serves as a kind of metaphor for the mental frameworks and belief systems we operate within. Our own conditioned realities have boundaries too.
That's an interesting parallel.
And the very fact that consciousness arises in a universe tuned for complexity, well, that opens up huge philosophical questions.
It leads back to our theme of individuality and context too, right?
Yeah, perfectly. These universal constants define the ultimate context. They allow for the rich chemistry that leads to biology, evolution, diversity, individual responses. Without this specific cosmic rulebook, none of that could happen.
Okay, from the mind-boggling scale of the cosmos,
Yeah.
let's bring it right down to Earth, literally, to the soil.
Yes, the soil beneath our feet. Another incredible example of fine-tuning, but on a totally different scale.
Because soil isn't just dirt, is it?
Not at all. It's a living, breathing, incredibly complex ecosystem. And its health, its fertility, which is vital for pretty much all land-based life, depends on this really delicate balance.
Physical stuff, chemical stuff, biological stuff, all working together.
Exactly. Soil health is really about its capacity to function, to support life, to provide these essential ecosystem services. It's not static.
So what are the key elements in that balance?
Well, first and foremost, you've got organic matter, carbon.
The heart of soil vitality.
Right. It's in the living roots, the microbes, the decaying leaves, the stable humus. Soil organic matter, or SOM, is maybe 50% carbon, and it's critical for everything. Holding water, retaining nutrients, giving soil good structure.
And that carbon is always cycling, moving around.
Constantly.
Yeah.
Plants pull it from the air, it goes into the soil, microbes break it down, some gets locked away. The balance of that cycle determines fertility, structure, and even how much carbon the soil can store away, which matters for climate.
Then you have the fungi, those mycorrhizal networks.
Yeah, yes. The soil's internet. These fungi form partnerships with the vast majority of plants, something like 80–90%.
Wow.
Their tiny threads, hyphae, extend way beyond the plant's roots, massively increasing the surface area for absorbing nutrients and water.
Like root extensions, basically. What do they help the plants get?
They're especially good at grabbing phosphorus, which doesn't move easily in soil, but also nitrogen, potassium, zinc, other key nutrients. Plus, they help with water uptake, drought resistance, even plant defense.
An amazing symbiotic relationship, and it's all coordinated, right? Complex signaling.
Highly coordinated. It's a co-evolved, finely tuned partnership, essential for how ecosystems work. And then you have the rest of the microbial zoo.
Bacteria, archaea, protists. Trillions of them.
An absolutely staggering diversity. And these microbes are the engines driving so many soil processes.
Like what?
Decomposition of organic matter, nutrient cycling, fixing nitrogen from the air, making phosphorus available, building soil structure with their glues and filaments, sequestering carbon. They do so much.
So it's not just diversity for diversity's sake. It's about functional coherence.
That's the key. Having the right communities, the right balance, working together effectively, that's what gives soil its resilience and allows it to provide all those services. And the physical structure they help create is vital for water and air movement.
It's this whole living web. And just like the universe has its parameters, soil health is shaped by natural factors too.
Absolutely. Temperature, rainfall, the type of rock it formed from, drainage, the plants growing there, acidity. These all set the baseline conditions, the natural tuning of that specific soil.
It almost sounds like you described healthy soil as a microbial superorganism.
That's a great way to put it. It shows emergent properties like self-regulation. It can buffer changes in pH, manage nutrient cycles, thanks to the microbial community. It really forces you to think holistically.
But this balance, it's delicate, isn't it? Especially with human impacts.
Very delicate. Modern industrial agriculture in particular can really throw things out of whack.
Things like monocropping,
Yeah.
growing the same thing over and over.
Yeah, that depletes specific nutrients, reduces biodiversity in the soil, can encourage pests, lead to erosion, and then there's the heavy reliance on synthetic fertilizers.
They boost plant growth short-term, but the long-term effects.
Can be harmful to soil life. They can reduce microbial diversity, mess up natural nutrient cycles, lead to acidification, salt buildup, even heavy metal contamination sometimes. And pesticides obviously have non-target effects.
Killing off beneficial bugs and microbes.
Exactly, disrupting the whole system.
Oh.
And then there's tillage,
Plowing, turning the soil over.
which breaks down soil structure, destroys those fungal networks, accelerates the loss of organic matter as CO2, and can lead to compaction from heavy machinery, makes erosion much worse.
So these modern methods, they seem to push the soil way past its natural balance point.
They often do, and this leads to widespread soil degradation. The FAO estimates maybe a third of global soils are degraded, and we could lose most of our topsoil this century if things don't change.
And a major consequence is our food becomes less nutritious.
That's a critical link. Degraded, depleted soil simply can't provide the same level of minerals and support the microbial life needed for nutrient-dense plants.
So the vitamins and minerals in our crops have actually gone down.
Studies show significant declines over the past 50, 70 years. Things like calcium, iron, zinc, magnesium, vitamin C. It's a real concern.
The nutrient density cascade. Depleted soil, less nutritious plants.
Yeah.
Impacting us.
Exactly. And soil, like other complex systems, has thresholds. It can cope with some stress, it can bounce back, but push it too far, too long.
And it crosses a tipping point.
Yes. It can shift rapidly into a degraded state, compacted, less fertile, less able to hold water. And its ability to self-regenerate is severely damaged. Reversing that is really hard.
It highlights the need for prevention, for regenerative approaches.
Absolutely. We need to keep the soil healthy, keep it above those critical thresholds.
I mean, this discussion about the soil as the external terrain, it really echoes our talks about the gut microbiome as the internal terrain. Terrain theory again.
It's a perfect parallel. The health of the soil dictates the quality of the food, which in turn influences the state of our internal gut ecosystem. Depleted soil contributes to depleted internal terrain. It's that ecological mirror.
And this shift towards industrial agriculture, disrupting that natural soil balance, that's a relatively recent thing in the grand scheme, isn't it?
Historically speaking, yes. The widespread adoption of intensive monoculture is quite different from many traditional and indigenous farming systems.
Which often had a deeper understanding of soil health.
Many did. Practices like polycultures, crop rotation, fallowing, using natural amendments, they often aim to nurture the soil, maintaining a more diverse and sustainable system. They worked with the fine-tuning rather than against it.
Okay, so from the soil beneath us, let's travel inside us to the gut microbiome.
Another fantastic example of fine-tuning ecological balance and those critical thresholds, right there in our digestive tract.
This massive community of microbes basically acting like another
A
organ.
microbial organ, exactly. And it's incredibly sensitive to our diet, stress, medications, genetics, everything, really.
And it affects digestion, immunity, even our mood.
Absolutely. It's this nested microcosm reflecting the same principles of interdependence and sensitivity we see in larger ecosystems like the soil.
So what defines a healthy gut ecosystem? Diversity is often mentioned.
Diversity is generally good, yeah. High species diversity in adults is usually linked to resilience, functional redundancy. But,
It's not the whole story.
right, it's an oversimplification to say more is always better. Functional diversity, what the microbes can actually do metabolically, might be more important than just counting species.
Function over form, in a way.
And the specific composition matters hugely. The relative abundance of different groups, having plenty of beneficial bifidobacteria and lactobacilli is generally good, and overgrowth of others might signal imbalance or dysbiosis.
And it's super individual.
Highly individualized.
Yeah.
Your genes, your diet, your life history, they all shape your unique microbiome. And there are keystone species, or genera.
Like in other ecosystems, species with an outsized impact.
Exactly. Things like bacteroids, Faecalibacterium, they play crucial roles in structuring the whole community and influencing our health, even if they aren't the most numerous. It's a finely tuned structure.
And these microbes are metabolic powerhouses for us.
Unbelievably so. They break down stuff we can't digest, like complex fibers.
Producing those short-chain fatty acids, SCFAs.
Yes. Acetate, propiant, and especially butyrate. These are fuel for our gut cells. They influence gut motility, modulate the immune system, even affect appetite and metabolism systemically. Huge impact.
They help with protein, plant compounds, even make vitamins.
They do. Vitamin K, some B vitamins. It's a true co-metabolism, a finely tuned symbiosis where their outputs are essential for our physiology.
And there's constant communication between us and them.
Constant dynamic chatter. The microbiome is crucial for training and regulating our immune system from day one, teaching it tolerance, keeping it primed against pathogens.
And the gut-brain axis.
That bidirectional highway. Neuronal links, hormonal signals, immune pathways, all connecting the gut and microbes to the brain. They can even produce or influence neurotransmitters like serotonin and GABA.
Affecting mood, stress, cognition. Wow.
It's profound. And dysbiosis, that imbalance, is linked to neurological and psychiatric issues too.
And you mentioned how sensitive it is to inputs, diet, obviously.
Hugely sensitive. Diet is probably the most powerful lever we have. Fiber types, fats, proteins, phytochemicals. They all selectively feed different microbes.
And ultra-processed foods.
Generally bad news for the microbiome. Low fiber, high additives. They tend to reduce diversity, favor inflammatory species, decrease beneficial SCFAs, potentially damage the gut lining.
What about stress?
Stress hits the gut hard, changes motility, secretions, immunity, indirectly altering the microbial habitat. Medications too, especially antibiotics, but other drugs can also have an impact. Our genes play a role. It's complex.
So it's constantly reflecting our lifestyle, our environment, our internal state.
Like a dynamic barometer.
Yeah.
And that finely tuned balance is always being negotiated.
And when that balance breaks down, dysbiosis.
Exactly. A departure from that healthy equilibrium, loss of beneficials, overgrowth of pathobionts, reduced diversity, altered metabolism. It's a functional shift.
With real physiological consequences.
Definitely. Increased gut permeability, leaky gut, driving systemic inflammation, chronic inflammation itself. Immune dysregulation.
And like soil, the gut can have tipping points.
It seems so. It can exist in multiple relatively stable states. A big perturbation antibiotics, major diet shift, chronic stress can push it over a threshold into a less beneficial, potentially more stable, unhealthy state.
Which makes resilience crucial, the ability to bounce back.
Absolutely key. And that depends on the starting diversity, those keystone species, the host microbe communication. It's this negotiated space constantly aiming for a balance favorable to both sides.
It really drives home that ecological mirror idea.
Doesn't it? The principles are the same. Diversity, balance, resilience, keystones, nutrient cycling, sensitivity, thresholds. What happens in our gut reflects ecological principles we see everywhere. Our internal health is an ecological concern.
And connects to so many things we've talked about, the gut-brain axis and mental health in EAP1.
Right. Microbial neurotransmitter production.
Histamines and that delicate balance in IP2.
Between producers and degraders like DAO.
Fiber selectively feeding microbes in F3.
Altering composition and SCFAs like butyrate.
UPFs disrupting the ecosystem in EP4.
Reducing diversity, increasing inflammation.
Terrain theory and microbial shapeshifters in EP5.
Context is everything for microbial behavior.
Microbes interacting with plant compounds in EP6.
Transforming them, affecting bioavailability.
And the microbiome myth in EP7, functional coherence over just diversity.
Exactly. It's about the coordinated output. And it links to nutrigenomics, our genes interacting with diet and microbes, and even intermittent fasting, how that influences the gut ecosystem.
It's all interconnected. Even linking to our plague discussions, a healthy gut supports immune resilience.
Absolutely. The gut is a major immune interface. And maybe even psychedelics, the gut-brain axis, suggests the microbiome state could influence response.
The internal ecological mirror. Wow. Okay, let's pull back again to maybe the most fundamental level of all. Life itself battling entropy.
Yes. At its core, life is this island of order in a universe that tends towards disorder, towards entropy.
Life fights against that tendency.
It does. Living things are open systems. They pull in energy and matter, use it to build and maintain their complex structures, keeping their internal entropy low negentropy.
While increasing the entropy of their surroundings, right? Exporting disorder.
Precisely. It's a thermodynamic requirement. And it's achieved through incredibly finely tuned mechanisms.
Like metabolism?
Metabolism is central. Building things up, anabolism takes energy and creates order. Breaking things down, catabolism releases energy to fuel the building and everything else. The balance and regulation are key.
And we're constantly repairing ourselves, too, fighting decay.
Constantly. We're bombarded by damaging agents. Think of all the DNA repair systems meticulously fixing errors in our genetic code.
BER, NER, MMAM, all those acronyms?
And protein quality control chaperones, refolding proteins, systems tagging damaged ones for removal and recycling, autophagy.
Keeping the cellular machinery working properly.
Exactly. These are active, energy-burning, anti-entropic processes, maintaining fidelity, maintaining function against the constant pull towards disorder.
And homeostasis, keeping our internal environment stable.
That's a huge part of it. Temperature, pH, nutrients, all tightly regulated through feedback loops. It's the signature of successfully maintaining biological order.
So when that maintenance system gets overwhelmed,
Then disorder starts winning. Chronic stress, not enough energy, faulty genes, too much accumulated damage. Internal entropy increases. Cells malfunction, tissues degrade, disease, aging, death.
even the information in DNA or how our brains process information, that's a form of order.
A profound form. Information guides the organization of matter and energy. Damage to that information mutations, neurodegeneration is an increase in informational entropy, leading to chaos.
But then there's this twist. Hormesis, where a little stress is good.
Yeah, it's fascinating. Low doses of things that would be harmful at high doses can actually make the system stronger, more resilient.
Though what doesn't kill you makes you stronger.
Yeah.
Principle biologically.
Kind of. These mild intermittent stressors seem to kickstart our defense and repair systems.
What gets activated?
Things like antioxidant enzymes, protein chaperones, DNA repair pathways, autophagy. Mitochondrial function can improve. It's like a cellular workout. The system gets preconditioned.
Like that entropic vaccination idea you mentioned. A small challenge boosts the anti-entropy response.
Exactly. It proactively strengthens the ability to maintain order. And this connects everywhere. Intermittent fasting, that mild metabolic stress, triggers autophagy, repair.
Plant compounds some anti-nutrients acting hormetically.
Right, like polyphenols activating defense pathways. Exercise is another classic example.
But chronic stress is different. That overwhelms the system.
Completely different. Chronic stress, like from UPFs, constant psychological pressure, chronic inflammation. It depletes resources, damages the repair machinery itself. It pushes the system towards disorder, towards entropy overload.
And quantum coherence in biology. That fits too.
Beautifully. It's life-creating and maintaining exquisite order right down at the molecular level, contributing to efficiency, stability, nigentropic function.
And flow states. That peak performance zone.
Likely depends on having a well-ordered biological system underneath. Good energy, efficient repair, balanced neurochemistry. A low entropy state ready for high performance.
Even plagues, pandemics,
Yeah.
massive entropic forces.
It's exactly. Individual and societal resilience depends on the pre-existing level of order and adaptive capacity.
And looking back at our evolutionary history, those intermittent challenges our ancestors faced.
Probably acted as hormetic stressors, shaping our resilience. The shift to modern chronic low-grade stressors might be messing with that evolved capacity. Maintaining order takes energy, and chronic stress drains the battery.
Okay, let's try to synthesize all this. We've gone from the cosmos to the cell, and this theme of fine-tuning, of life thriving in narrow, balanced conditions keeps reappearing. The ecological mirror.
It really does. These vastly different scales reflect common principles, fine-tuning, interdependence, thresholds. And seeing these reflections gives us powerful clues about health and sustainability.
So let's tackle those core questions. Why does life exist in such a narrow range?
Well, cosmically, it seems the fundamental laws had to be this way for complexity to even arise. A tiny tweak, and no life as we know it.
And biologically. Soil, gut, cells.
Same principle. They all require specific conditions, the right moisture, pH, microbial balance, temperature, nutrients. It reflects the requirements for complex, self-organizing systems to persist against entropy within these precise universal laws. Life isn't infinitely adaptable.
It really gives you a sense of humility,
Yeah.
how precious and specific life is.
Definitely. And what can the cosmic tuning teach us about balance in our food systems, bodies, culture?
What's the takeaway metaphor?
That systemic balance is key. Just like the constants work together, our systems need balance among all parts. Health emerges from the whole, not optimizing bits in isolation.
And the importance of thresholds.
Crucial. Tiny cosmic changes is huge effects. Same in biology. Soil loses resilience, gut tips into dysbiosis, metabolism breaks down, crossing thresholds leads to dysfunction, respecting limits is vital for sustainability.
And that ecological mirror, our internal health, reflects our external world.
Indivisibly linked. Soil health impacts food quality, impacts gut health, impacts overall well-being. You can't separate personal and planetary health.
And this drive towards complexity we see everywhere.
Yeah.
Is it just an accident? Or is there a point to it?
Science struggles with point or purpose, but the fact that complexity consistently emerges and sustains itself in this finely tuned universe is remarkable.
From photosynthesis to DNA repair to microbial networks.
It suggests complexity isn't just a fluke, but maybe a fundamental tendency of life within this framework. It links to evolution, adaptation, and the emergence of consciousness itself.
Tying back to all our themes, anthropic principle, context, threshold.
Exactly. The anthropic principle is the ultimate context dependency. Thresholds are everywhere. Understanding them is key to health and resilience. Sustainability becomes fostering ecological coherence, not static control. And health is that emergent property of a balanced, finely tuned system.
And these principles operate fractally. As above, so below, so within.
It certainly seems that way. Common patterns of organization across scales, which, again, leads to that sense of ecological humility.
We're participants, not masters, dependent on these delicate balances.
We are. And that understanding encourages a more careful, respectful way of interacting with the world and our own bodies.
So wrapping up, health, at any level, can be seen as this emergent property of coherence.
Yes. Arising when systems are in dynamic balance within their fine-tuned limits, nourished properly. It shifts the focus from just fighting disease
To proactively cultivating coherence.
Exactly. We've seen this theme of life thriving in narrow parameters from the cosmos to the cell. It underscores the importance of terrain, of context.
We've seen how chronic stress disrupts order, but also how resilience can be built through hormesis and repair.
And the big lesson maybe is to shift focus away from reductionist control towards nurturing the conditions for life's inherent wisdom and self-regulation to flourish,
Fostering diversity, balance, feedback, respecting limits.
which requires that profound ecological humility, realizing we're deeply interconnected, deeply dependent participants in this incredible dance.
So it calls for a more integrated way of living.
One that weaves together ancestral wisdom, the power of our minds, and these fundamental biological and physical laws.
Ultimately, the path to a sustainable, vibrant future for us, for the planet, seems to lie in cultivating that coherence at all levels.
Respecting and supporting the extraordinary fine-tuning that makes all of this possible, within us and all around us.
Thank you for taking this deep dive with us today.